All right, so my name is Pascal Poupart. So I'll be telling you about 3 courses, starting with this one, Artificial Intelligence. So some of you may have seen, plenty of movies that talk about artificial intelligence. So now you're going to get to find out how really things work in artificial intelligence. So unfortunately, things are not as advanced as in the movies. Okay, so I got to tell you this right off the bat. It's a very fun course. I would highly encourage you to take it. And there's some really interesting topics. The course is offered any term, so fall, winter, spring. There are several instructors. It could be any one of us, so Chrysanne DeMarco, Kate Larson, myself, or Peter Van Beek. And the textbook that we use is called Artificial Intelligence, A Modern Approach. It's a very thick textbook, but it's a very nice one, and I would highly recommend it. So next slide. OK, so what are the topics we're going to talk about? Search techniques. So you can think of a lot of problems in real life that once you axiomatize them, you try to automate them, they really boil down to search techniques. So for instance, how are the schedules made for exams and courses and so on? That could be tackled with constraint programming. Or how do you play some games like Sudoku and so on? That's also an instance of local search. Beyond search, we're also going to look at reasoning under uncertainty. So in a lot of problems, very often, things are not exact or black and white, but there's a bit of a gray area. And it's difficult to get computers to deal with things when they're missing information or the information is noisy. So here, we're going to look at different models from probability theory, including Bayesian networks and Markov networks, to deal with this sort of issue. So some of the applications here would be, for instance, credit card fraud detection, information retrieval, how to do a medical diagnosis, fall detection, and many others. Some more topics. Decision theory. So once you can reason about the uncertainty, you'd like your computer to make some decisions, and perhaps the best decision possible. So we get to axiomatize this as well. And this will lead to some models like decision networks and Markov decision processes. And these are very useful in lots of applications, especially in operations research. And a lot of companies actually require this sort of technology. And finally, the last topic is machine learning. So this is a branch where we're looking at how the computer could adapt and perhaps have algorithms that would learn from data as opposed to, I guess, you programming the algorithm directly. Okay? So again, this is very useful, and there's a lot of demand for it, especially in natural language processing, health informatics, or anything where there's lots of data. Okay? So in terms of logistics, then past students generally say that the course is average for the workload. It involves some assignments. Typically, there's some programming, but there's also some theory. Depending on who's teaching the course, we may use the Alchemy package, which is a fun package to do some interesting programming at a high level, especially in natural language processing. There's also a midterm and a final. And then, depending also who's teaching it, there's likely to be a project where you can basically take a topic of your choice and just go wild with it. Okay, are there any questions regarding the course? Yeah.
So I think there's supposed to be, for machine learning and such, there's a lot of math background that may or may not be required. Like, is that something that's recommended for people who are interested in this course?
Yes. So actually, is there one more slide? No, OK, so I thought I had a slide with the prerequisites. The prerequisites are, I guess, CS 341 and I think Stat 231. OK, so you need to be comfortable with algorithms, the analysis, and so on. And then for reasoning under uncertainty, machine learning, and so on, it's mostly statistics that you need to know. Beyond that, I guess if you know some linear algebra and optimization, this would be useful. But the course is self-contained, so we're going to teach what's necessary. Yeah?
I noticed that the textbook you're using was verified already.
Yes.
What do you think about the AI class that you're offering?
That's a great question. OK, so unfortunately, I haven't listen to the course that's offered, I would guess that it's a very good one. What tends to happen is that AI is such a wide topic that I doubt anybody, including Peter Norvig, can teach everything that's in that book. So different instructors will typically have a different focus on different parts. Yeah. Okay, so, all right, let's move on to the next course. This one is called Machine Learning. So it is different. I mean, we just saw that for artificial intelligence, there is a section at the end about machine learning, but there won't be any significant overlap with this course. So this course goes into more depth about machine learning. And to take this course, you don't need to have taken artificial intelligence. Okay, so they're set up in such a way that you can take each course separate and in any order. Okay. So for this course, either Shai Ben David or myself will be teaching it. In fact, for winter 2012, I will be teaching it. We're going to use those two textbooks, so Pattern Recognition and Machine Learning by Chris Bishop, and also a textbook that Shai Ben David is currently working on called Machine Learning, From Theoretical Principles to Practical Algorithms. Okay? And here, the main question we're trying to address is how can computer adapt by learning new concepts from examples? So here, I guess the idea is that at some point, several decades ago, people thought, well, wouldn't it be nice if we didn't have to program computers and they could just, learn from examples in the same way that we do. And although computers still cannot do that yet, at least not to a large scale, what is very useful is what if you have lots of data and you'd like to essentially analyze it and extract some interesting conclusion. So we know today that with the internet and large databases, there is tons of data, and it's actually a challenge to extract relevant information. So machine learning is essentially the main tool that allows us to analyze data. Okay, so in terms of examples, then if you've ever wondered how does spam filtering work, well, you can specify some rules, but in general, it would not be robust. So one approach is that you could simply have your computer try to learn those rules simply based on emails that you've already classified as spam or not. And some of the best techniques often use this more machine learning-like approach. Data mining, very important, how to recognize patterns in a data set, for instance, fraudulent transactions. In robotics today, it is also becoming the norm that people don't program the robots directly because it's just very hard to come up with all the possible situations. Instead, you simply let the robot do its thing in the environment and kind of adapt. And you design more like a meta-algorithm that will learn from the experience of the robot. And then finally, for natural language processing, then you could ask questions like, how could we cluster news articles by topics? And there are news articles that appear on the web all the time. And if we try to do this manually, it's just not going to be fast enough. But you could do this using machine learning techniques. Okay. Okay, so in terms of topics, we're going to talk about the theoretical foundations. So this includes learning theory and Bayesian learning. Then we can divide machine learning in roughly 3 broad areas: supervised learning, unsupervised and semi-supervised learning, as well as reinforcement learning. And then we'll see some specific algorithms within each one of them. Okay. And then, okay, if you want to take this course, you need Stat 206 or Stat 230. So statistics are very important because that's the way that I guess we can analyze data, so by looking at the statistics and deriving some interesting conclusion. And then algorithms, again, CS341 or CM399 is very important. In terms of assignments, there will be some programming and some theory. MATLAB is a recommended language, but in general, you can use any programming language for the assignments. There's a final exam, but no midterm. And then there's going to be a project, and here it's meant to be fun, and you can earn some bonus marks as well. Okay? And all right, so I'm going to tell you about one more course, computer vision, which is, oh, it crashed?
PowerPoint didn't like that.
Okay. Then I'll just talk about it then. Yeah, let me just see what I have here. Okay, so computer vision is going to be CS484. The instructor for this is Richard Mann, and it's offered, I believe, every fall term. So the next instance would be fall 2012. And in this course, the problem is essentially how can we analyze an image and extract information? So you can think of computer vision as being really the inverse of graphics. So in graphics, you have something that you'd like to render on the screen. Now in computer vision, you've got an image and you need to extract the information. What is the scene that's being described? And I mean, we do this with our eyes every day without thinking about it, and it's not a big deal. But now what the computer really gets to see is just a huge array of millions of pixels. And this is just an array of numbers, right? How can we make sense of this? So it's actually a very difficult problem, but it's very relevant because cameras are a very general and universal sensor, very rich, and so you can use it for all kinds of application, whether it's for surveillance or just trying to do, I don't know, some gait analysis in kinesiology. So there's lots of interesting applications. Okay, so if you want to take this course, for the prerequisites, you need CS370. So that's numerical computation and some MATLAB experience. The grading, there's going to be 4 assignments that are worth 50%, as well as a final project that's worth 50%. And the textbook is by Trucco and Very called Introductory Techniques for 3D Computer Visions. And the instructor will also provide some notes. Okay. In general, so what will be talked about more specifically in the course will include a bit of signal processing. There will be some model selection and fitting, as well as interpretation, in other words, classifying objects, motions, and behavior that are captured by a camera.